So in this lecture and the next one, I want to look at some kind of practical problem-solving techniques, right? Some things you can do to approach specific problems that you come up with. Yeah, obviously I'm focused mostly on math problems, but they apply to other things as well. Some, for example, are I commonly use in my day-to-day work as a software developer. Right? Others I think you'll find can be useful in working on day-to-day problem solving. So the first one I want to talk about is naming strategies. When you're naming your variables, mathematicians, I have a tendency to default to x and y, right? Because those are kind of our standard math variables. But another thing I do a lot, and this kind of comes from my experience doing software development, try to pick variables that relate to what they represent. For example, if I'm talking about the area of a box, I'm not going to call the length and width x and y, right? I'm going to call them L and W, right? Because L helps me to remember that this is the length and this is the width. So when you start sticking them into formulas, you know which one is which. And more important, when you get to the end result and you see W equals a number, you know that number is the width. Or if I just call it X, I'm going to have to go looking back on my thing. Okay, what did X represent again? Right? So kind of pick letters for your variables that have a connection to the things they represent. So another thing I like to do, I'm a very visual person. A lot of people I work with, a lot of students, very visual people. Whenever you're talking about something physical, like a pool or a box, or if you're talking about the distance between points on a map, right? Draw a picture. Right here, for example, I know I have a rectangular pool, right? And it's 14 by 10. And I'm going to put the dimensions on here, 14 by 10. And it's got a tile border. So I'm going to draw a border around it here. This is the problem with my making drawings. My artistic ability is massively limited. You're kind of seeing that here. And I'll label this 3. Right? And then when I start working on the problem and I start adding numbers and stuff based on what I calculate, if I'm doing this on the board in class, for example, I'll get another color out. And I'll use another color pen to represent the things that I calculate versus the things that I was given in the question. So another approach we use is be systematic, right? I'm trying to figure out how many ways can 3 people be seated in a row of 3 seats. Well, there's a formula for this. There's a technical way to do this, but it's a relatively small group, right? So one approach here would be to just write them out, right? Write out all the combinations. So I'm going to start off by saying I'm going to let A equal Alice, B will be Bob, and C will be Chris. You notice how I chose my variables, right? Going back to my first suggestion, right? The variable name correlates to the name of the person. Okay, so now I'm going to start writing them out. What I'm going to do, right, is be methodical. I'm going to write out all of the seating arrangements that start with Alice. So I can do Alice, then Bob, then Chris, or I can switch the second 2. Okay, so those are all the ones that start with A. Now I'm going to take the next step. I'm going to do all the ones that start with B. Well, I could do B, then A, then C. You notice I'm going alphabetical for my first one, right? Then I could also switch C and A. And then finally, I'm going to do all the ones that start with C. And now I know I'm done, right? I've done all the ones that start with A, all the ones that start with B, all the ones that start with C, and there are no other people in the room, right? So now I'm confident that I didn't accidentally leave one out, right? Now I can add these up and see that there are 6 total possible arrangements. Okay, another technique we use is looking for patterns, right? I've got these numbers here. And the question, what's the question? What's the next number? Well, you got to look for a pattern in the existing ones. And what I'm seeing here is First thing that jumps out to me, or first thing that jumps out, all the numbers in the list are even, except for one. Okay, the first one was strange. All the other numbers in the list are even, right? So I'm thinking I'm looking for an even number. Now how can I go from one number to the next? Well, look, if I multiply by 2, 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. So I'm gonna guess here, I'm gonna infer, so it's an educated guess, that my next number is going to be 16. Another thing you could see, maybe some of you saw this, right? Maybe some of you noticed all the numbers on the list are powers of 2, right? 2 is 2 to the first, 4 is 2 squared, 2 is 2 to the third, and it does work going down this way. 1 is 2 to the 0. So notice what's happening to the exponents. The exponents are going up by 1 every time. So this would lead me to believe that my next number is 2 to the fourth. Yeah, 2 to the fourth is 16. Look at that. It works that way too. Okay, another method. Look for specific examples, right? What can you say about the sum of 2 even numbers? Well, I don't know. Let's look at some. Right, let's look at some examples. I'm going to say even, let's pick 2 even numbers, 2 and 6. 2 plus 6 is 8. Okay, well, that's just 1, or I don't have a lot to go on yet. So let's try another one. How about 8 plus 12? Well, that's 20. Okay, well, maybe I'm seeing something, but 2 isn't a whole lot either. Let's try a few more. Say I do 16 plus 4. Well, that's also 20. Okay, now I'm starting to think I see something. Right? Can't help but notice that all the numbers I've come up with here are even. Okay, but as a mathematician, a math professor, I'm skeptical. I've picked all positive numbers. Maybe positive numbers are special. Maybe it's not going to work when I pick negative numbers. Okay, so let me pick negative numbers. Let me do negative 10 plus negative 8. Well, that's negative 18. And yeah, look at that. It's still working. Okay, well, let me keep going. Let me try another one here. How about a positive number and a negative number? Let's say I mix them. Let's say I do negative 16 plus 4. Okay, well, that's negative 12. And yeah, now I've done 5 examples. I've mixed them up. I've tried to make sure, I didn't accidentally pick something weird in the beginning. Now I'm starting to think I can come up with a conclusion. This is leading me to believe that the sum of 2 even numbers is an even number. Okay, so this is what I mean by look at examples, right? Check out some numbers, right? See if you can spot a pattern. Because there's the first 5, or my first 5 practical strategies. So in the next lecture, we're going to look at 5 more of these, see if we can't build up a toolbox for you to work with.